For 11.5 notes, it says finding the perimeter and the area of similar figures. So for this one, the ratio of the perimeters is A over B, and the ratio of the areas are A squared over B squared. Let's get into what this actually looks like. So for this one, it says, what is the ratio from the smaller to the larger of the perimeters? So the smaller figure to the bigger figure of the perimeters. So I would look to say, okay, well, if I compare the side lengths, 6 over 9, and that would reduce to 2/3. Okay, so we could say 2/3, or you could write it like this. You could also write the word 2 in between it. Either way is fine, but most of the time we're going to write it like this. Okay. For part B, what is the ratio smaller to larger of the areas? So you take the ratio, basically your scale factor, and you square it, and that would be 4/9. Okay, if you really want to write it 4 to 9, you can. Now I'll tell you in the assignment, the quick check, it's hard to do fractions in there, so I'll probably write them like this, just because it's a little bit easier to do and faster. For example 2, finding areas using similar figures. So for part A, you're given that two similar figures are in a ratio of 5 to 4. What is the ratio of the areas? Okay, so you just take the 5/4 and you square it. So we would have 25 to 16. Again, that could be 25 over 16, either way. But what happens if you need to go backwards? So it says a regular hexagon has an area of 36. Find the scale factor of this hexagon to a similar hexagon with the area of 121. So here's your smaller hexagon, bigger hexagon. So if I want to go backwards, I need to take the square root of each one of these to go to the scale factor. So the square root of 36 is 6. Square root of 121 is 11. This cannot be reduced. So it's just 6/11. All right, letter C. The area of the smaller regular pentagon is 27.5. So I'm going to note that this small pentagon is the area is 27.5 centimeters squared. What is the best approximation for the area of the larger pentagon? So area of this is unknown. Round to the nearest whole number. Okay, so we have a few things to do. I'm going to number them. 1, you need to find your scale factor. Okay, so 4/10 is going to be 2/5. Okay, that is scale factor. 2, you want to take the scale factor and you need to find the area ratio. So you would square it. Okay, so this is area ratio. Alright, so that's 4/25. You basically did this when you went from here to here. Okay, so just like example 1. Alright, now that you have the area ratio, you take the area ratio and you say, well, if the small area is 27.5 and this 4 represents the small pentagon, then I can figure out the larger area based on this ratios, okay, or proportions. So I would cross multiply, so 4x equals 25 times 27.5, and that gives me 687.5. If we divide by 4, we get 171.875. And it says to round to the whole number, nearest whole number, so the 8 makes the 1 go to 172 centimeters squared. Okay. And then this, you could state, like, you know how we wrote scale factor, area ratio. This would be finding area of larger pentagon. Okay, so this one is very, very similar to what we just did. Okay, the area of the smaller trapezoid is 85 centimeters squared. So we're going to go with this is the smaller one just because when you compare the sides, you know that 8 is smaller than 24. They do look pretty much the same. They're not congruent, they're similar. Okay, so this is 85 centimeters squared. So step 1. Got to find the ratio, the scale factor. So 8/24 becomes 1/3. Okay, then take the 1/3 and you're finding the area ratio. So 1 squared, 3 squared, 1/9. Step 3, you take the area ratio and you set it equal to the area given. Okay, you know the smaller trapezoid is 85, so that goes on top. You're finding the larger one. Okay, so we have 1x equals 9 times 85, and that is 765. Divide that by 1, you still get 765. And since we're finding area, that would be centimeters squared. Okay. Now, this one was given on one of the quick checks, and there's no picture, and I just think it's a little bit different, but it's also similar to what we just did. But I also think it'd be good to see this without a picture. Okay. So the ratio of the lengths of corresponding sides of two similar triangles is 1:2. Okay, so you're already given step 1. It's 1/2. Step 2 says find the area ratio of that 1/2. So 1 squared to 2 squared. So 1/4. Step 3 says, well, take that area ratio and let's set it equal to the area. So it says the smaller triangle has an area of 21 square centimeters. So that's the smaller triangle. What is the area of the large triangle? That's your question. So that's x. Round to the nearest whole number if necessary. So 1 times x is 1x, and 4 times 21 gives me 84. Okay, so 84 divided by 1 is still 84. All right, so in this problem, we didn't have to find this. This was given, and over here, the very first step is that we had to find it. All right, moving on. Example 3A. So this one has quite a few things. It says the triangles at the right are similar. Okay, this should be below. Below are similar. What is the scale factor? And then what is the ratio of their perimeters? All right, so the only thing you're given, though, is the areas. So how do we go from area to scale factor? So if I notice, these are not perfect squares because I want to do the square root of these, and they're not perfect squares. So now I'm like, okay, well, can I reduce this in some way? Yep, they're both even numbers, so automatically they're going to reduce or divide by 2. So I get 25 and 49. Okay, aha moment. These are perfect squares. So now I can take the square root of each one and get 5/7. In the very first part of the notes here, your scale factor, A over B, is the same as your perimeter scale factor. So once you have scale factor, you have the perimeter scale factor. So it's just 5/7. So that answers both questions up there. All right, part B, same exact thing. That would be below. So I have 48 and 147. And I know that absolutely I cannot take the square root of these. These are not perfect squares. Okay, so I got to figure out what can divide, what can reduce. I know it can't be 2. So let's try 3. So 3 goes into 48 16 times. 147 divided by 3 is 49. Okay, so we have perfect squares. We square root each one, and we're going to get 4/7. Can't reduce that, so that's good. 4/7. Okay, now down here in letter C, this is the same thing. It's just not having pictures. Okay, so I want to make sure that you'll see that in the quick check you're going to have some with images, some with just writing. So the areas of two similar triangles are 120 centimeters squared and 270 centimeters squared. What is the ratio of these sides? Let's put up here real quick. If they're not perfect squares, you have to remember that you are reducing first. So we set up that fraction, 120 over 270, and automatically I know that if you have zeros that match up, they cancel out. So we're looking at 12 over 27. And 3 can go into that, or both those numbers. So that would be 4 and 9. So square rooting 4 and 9 gives me 2/3. And that's it.